stuff that's just sort of introduction. It's going to be connected to stuff that you see. No, just watch it and I'll put it on. I'll make a video for it. It's connected to what you'll see on page 444. So these are your angles, non-calculator. Here are our non-calculator angles in other quadrants. One of the special triangles we learned was the 45-degree triangle. And what we did is we made this 1, 1, and root 2. Because we did a squared plus b squared equals c squared, because we knew it was an isosceles triangle. And then from that, you knew that sine of 45 degrees was root 2 over 2. Cos of 45 degrees. Of course, first you would look at the triangle and get 1 over root 2, then rationalize to get root 2 over 2. And tan of 45 is 1 over 1, which is just 1. So there's our first triangle. Now, what we know about angles is that they're related by their reference angle. And we've also learned the cast rule, which tells us in which quadrants the different trig functions are positive. All of them are positive in quadrant 1. But in quadrant 2, only sine is positive. So now if we draw this same triangle in quadrant 2 and make a reference angle right there, that reference angle will also be 45 degrees because it's exactly the same triangle. These lengths, because it's the same triangle, will be exactly the same as well. But now the angle that we're talking about is this one, 135 degrees. So now you can tell me what sine of 135 degrees is. Okay? Because it has the same reference angle as 45 degrees, it's going to equal the same thing. And because it's in quadrant 2, sine is going to be positive. Cos of 135 degrees is going to be the same as cos of 45 degrees, but this time it's going to be negative because according to the cast rule, only sine is positive in quadrant 2. And what will tan of 135 degrees be? Okay, tan of 45 degrees is 1, so tan of 135 degrees will be negative 1. It's exactly the same triangle, so your ratios are the same. The only thing that changes is whether it's going to be positive or negative. So now if we went to quadrant 3 and drew the exact same triangle in quadrant 3, again, always to the nearest x-axis so we can have a reference angle, and this is 45 degrees. This could be 1 and root 2 again, but now the angle that we're talking about here would be 180 plus 45, or 225 degrees. So now we can do sine, cos, and tan of 225 degrees without our calculator. Well, it has the same reference angle as 45, so it's still going to be root 2 over 2, but now that it's in quadrant 3 only tan is positive. So both sine and cos of 225 will be negative, and tan will be positive. The only quadrant we haven't done, quadrant 4, same thing would happen if you did a reference angle here, 45 degrees, 90 degree there. Now we're looking at this angle. This will be 360 minus 45, 315 degrees. You can now do sine, cos, and tan. Which one's going to be positive? Only cos. Sine and tan will be negative. You could do the same thing with your 30-degree triangle and redraw it in all quadrants. So now What's sine of 30 degrees? Half. So now what's sine of 150? Because it has a reference angle of 30, also half. What's sine of 210 degrees? Has a reference angle of 30 degrees, so it's going to be a half, but it's in quadrant 3, so it's going to be negative a half. So once you have quadrant 1, you now can figure out all the other quadrants without your calculator, as long as you figure out the reference angle first. So what's going to happen is you're going to get a question that looks like this. What is cos of 300 degrees without your calculator? You're going to imagine 300 degrees is where? In which quadrant? Quadrant 4. Here's 300 degrees. What is our reference angle? Our reference angle is 60 degrees. Is that one of the ones that you know without your calculator? Yes. What is cos of 60 degrees? Cos of 60 degrees is 1/2. So cos of 300 degrees will also be a half. Will it be positive or will it be negative? It'll be positive because it's in quadrant 4. That's the kind of ideas that you're going to go through for figuring these out. So on page 344, they have the special triangle and they go through the angles for 45 degrees. At the bottom of page 344, they introduce new ones that you're going to figure out. 444, thank you. Now, right beside this one that has 0, 90, 180, 270, and 360, what we're going to use to help us remember what sine, cos, and tan of 0, 90, 360, 270 are, is we're going to learn what the graphs look like. So we are going to graph y equals sine x and y equals cos x. We're going to graph for going around a circle once, so for 360 degrees. So what we're going to do is we're going to mark a point here at 360 degrees. We're going to mark halfway at 180 and mark half of those, 90 and 270. Yes, write this down beside the graph, beside that chart. Leave space for the graph of sine x and the graph of cos x. So this is how much space.
The bottom chart?
Yeah, the one at the bottom chart. And what we're really doing right now is sort of developing some of the key ideas that are really looked at more in depth in the grade 12 course next year. On the y-axis, we're going to have it go up to 1 and down to -1 for both of them. And what happens with the sine graph starts at 0, then goes up to its maximum, back to 0, and it makes a nice smooth curve like that. And it keeps doing that curve up and down forever. But we're just going to graph the first little bit here from 0 to 360. And the graph of cos starts at a maximum Oh, thank you. Whoa, my graph got a little bit high over here, hey? It's supposed to still only be at 1. And this one keeps repeating itself over and over again. So if you know these graphs, you can now figure out the exact values of 0, 90, 180, and 270, and 360 by looking at the graphs. So if I said, what is sine of 90 degrees? You look at your graph, go to 90 degrees. Sine of 90 is 1. If I say, what's cos of 270 degrees? You go to your cos graph. Where's 270? Right here. Cos of 270 is 0. So if you know what the graph of sine and cos look like, then you can figure out 0, 90, 180, 270, and 360 just by looking at the graph. They are very similar, as you can see from the graphs. Sine starts at 0, 0, going up, and cos starts at its maximum. And then each time it goes from the maximum back to the middle, then to the minimum, and so on and so forth.